All right, this is a tutorial on how to do 2.6 optical illusions. So I'm assuming you went through number 1 and you watched the video and you wrote your ideas for how this arrow could switch spots. So the next part says 3, gather data by going into the PhET simulation bending light. So it looks like I don't have a link, but I will make sure you have a link. So if I even type in PhET bending light, it's going to pop up. And this is what the PhET simulation looks like. So I'll make sure I have a link right here into the lesson. So you should have it now. Okay, so with this PhET simulation bending light, it says draw what happens to, set the top of the air and the bottom to water, draw what happens to light in both mediums, label what you think is refraction and what you think is reflection. So if you go on to this, top is air, bottom is water, and you push play here, you can see that there is a light. Now you could draw this, well, first of all, let's show you that if you bend it, you can see that you're changing the angle here and you're changing the angle here. So I want you to tell me, the question is which one is refraction and which one is reflection. So you should be labeling these two labels as refraction or reflection. So I'm going to take a screenshot of it. Yours is using the control Windows button. Mine is a snipping tool. So here I'm taking a picture of it. I don't even have to have the whole screen, but part of it. I can copy it and then I can paste it into my document here. Now if it seems too big or crazy, you can always minimize it and make it go smaller. But one thing I kind of like to do is I like to make this as part of the Google Drawing so I can write on it. So I'm going to copy this one more time just to make sure it's there. I'm going to go Insert, Drawing, New Drawing. I'm going to paste it here, which is Control V as in like van. And now I can label which one I think is reflection and which one I think is refraction. So I can click reflection and I can put it on either spot that I think it is. And then you'll need to do the same one for the word refraction. All right, and then you can save and close and it should be here. And then you don't need this one here. So that's the first thing, is to get a picture of what happens when you have light go down. Okay, the next one is to, in the PhET simulation, click on More Tools. So if we go into More Tools right here, here's our first thing. And then it says to set the simulator to round 1 described below and record your data. So the top is air, the bottom is water. So air, this one says glass, so I better fix it to water. And then I'm going to again start here. And then if I look back here, it says top air to water, and then it says angle and intensity. So you can choose the angle that you like, but you better record the angle. So this is I believe it's a protractor, and I have it all lined up to 0 at that one line and 90, right? So if both are at 0 and 90, we're set. So I can set this wherever I want. I can say 60 for my angle here, and then I can see what the measurement is on this side. So it would look something like this. We would type in 60, and the angle for the water when it comes out as 60 is going to be, here's 30, here's 40, here's 50. That looks like a 41 to me. So I'd come back into here and I would type in 41. So that's how you do the first part. The next one is to measure the intensity. So if I put the intensity here, it says 100% intensity. So I can put it there. So if I come back over here, I can just type 100% intensity. The bottom water, now I'm going to see how much the bottom water's intensity is. So if I put it here, it says 88.23%. So I'd go 88.23%. Oops, not a dollar sign. Okay. Then it says time faster or slower. So if I put this tool back, I've got a speed tool here. If you change it to wave, you can actually see this one goes fast, and then you can see it slows down, and it kind of helps you. So this is 1c, meaning it's the speed. C stands for the speed of light. So that's cool. This is traveling at the speed of light. And this is traveling at 3/4 the speed of light, 0.75 c. So you can do it either way. You can write that this one is faster, and you could even write 1c, or you could even write the speed of light. Then you would come over here and you would say slower, and you could even say 0.75 c, which is 3/4 the speed of light. Oops. Okay, oh, I could have read ahead. And then it says speed in C over here, so this one needs to go here. Sorry, I should have read ahead. And this one goes here. All right, so that's how you do that problem, and I'll make sure that this comes in red for you guys so you can see it when you're doing this assignment. All right, so you're going to do the same thing. You're going to put air to glass, you're going to do air to mystery substance A, and air to mystery substance B. And then I want you to give a logical guess of what you think the material A could be based on what you find. Oh, that's annoying that it just did that. Let's come back over here. And then what you think type B is. All right, perfect. Let me pause so I can get this. All right, so to continue on, this is sound part 1. We're going to click on this website, and you might need to be able to hear this, because if you don't hear it, it won't work. So I don't know if you can hear this, but it just pounded on this, and then the voice says, much later, it says hello. So it says now you hear the voice much later. So why is that? And so think about if this was an aluminum pipe, it was traveling super fast at 6,320 meters a second. But when it traveled in the air, it was 343 meters a second. So when you explain that, you're going to come over here and you're going to just type in your answer that if sound travels through the solid metal, it arrives much sooner since sound travels faster in a solid. And then you can say something like, because sound is slower in air, the person's voice arrives later. Something to that extent. And then you can even say that data if you wanted. You could even point out, okay, the data for this you have is 343 meters per second for air, and for copper or aluminum it's 6,320 meters per second. Okay, so that's how to do that one. Going on to the next one, this link shows you the speed of sound in different materials. So if you click on here, it will go through, and you can see, you can have it typed in right here at 20 degrees Celsius, and you can calculate and you can see what the temperature is. So that will help you answer like that one. If you go here, it's 343 meters per second, and then you can change the temperature. And then when you want to see water at 15 degrees Celsius, this one you just scroll down and there's a data table that goes through all of them. Not that one, there it is. So this allows you to go through the last ones, and you can do the sound in meters per second there. All right, so it says explain through writing or a picture to describe why these patterns exist differently for light and sound. I'd like you guys to do this on your own, and then I'm going to start tomorrow off making sure that everybody who has the right answer here will get additional points, and we will go through reasoning number 4 together. I am fully confident that you can complete this assignment on your own. When you finish this assignment, I expect you to go into Canvas and to finish any missing assignments. I will put an additional assignment up as well, most likely. Thank you, good luck, and be kind to the sub.